Okay, this is Chapter 8, Section 2, Polygons. Make sure you understand that the word prefix poly means many, gons means sides. So these are many-sided shapes. So for instance, if we look at this here, we can see that in terms of this one here, we have 1, 2, 3, 4 sides. So that is a four-sided shape or four-sided polygon. Here we have 6, here we have 6, here we have 3. Now, this is termed a quadrilateral with 4 sides. This is a hexagon. This is also this is a pentagon, so to speak. This is a triangle. So that, straight line segments that form the polygon are called sides. Point where two sides meet is called a vertex. And so you have vertices. It says the union of the sides of a polygon and its interior is called polygonal region. And a regular polygon is one whose sides are all the same length. So make sure that's an important concept right there. A regular polygon is one where all the sides are the same length, like this one here. This would be a regular polygon because it's an equilateral. This would be a regular polygon, okay? And so you have this little chart here which tells you, 3 sides triangle, 4 quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon. When we come over here, the measure of interior angles. So the sum of the measure of interior angles of an n-sided polygon is this n minus 2 times 180. So however many sides you have, like if you have 6 sides, so you subtract 2, you got 4. 4 times 180 tells you the total area or total degree measure of the inside angles are 720. And so here's this chart here with the same thing. We have sides, 3, which is triangles. How many triangles do we have? If we have 4 sides, we have 2. If we have 5 sides, we have 3. If we have 6 sides, we have 4 triangles. And so as a consequence, all they're doing is they know a triangle has 180 degrees total. So they go 1 times 180, 2 times 360, 2 times 180 gives them 360, 3 times 180 gives them 540, and 4 times 180 gives them 720. All right? So when we come over here, there's a chart describing the different triangles. We have an acute triangle where all the interior angles inside are less than 90, but add up to equal 180. We have an obtuse triangle where one angle is greater than 90, the other two are acute. We have a right triangle where we have a right angle. An isosceles triangle where 2 sides are the same, so the the angles opposite those sides are the same. The equilateral triangle where all 3 angles are the same and all 3 sides are the same. We have a scalene triangle. No 2 sides are equal in length. Okay, this is dealing with length. This is dealing with angles. Acute triangle deals with no angles are the same. Scalene triangle deals with no 3 sides are the same. All right. We talk about similar. 2 figures are similar if their corresponding angles have the same measure and the lengths of their corresponding sides in proportion. So in terms of this, we have a big triangle and a little triangle. So here we have triangle ABC, and it's larger. Here we have triangle DEF. So in similar triangles, angle A is the same as angle D, angle B is the same as angle E, angle C is the same as angle F. In the same proportion. The angles are the same. The sides. Proportionally, side CA is proportional to FD. Side CB is proportional to FE. And side BA is proportional to ED. So when we deal with similar figures, here we have similar figures, and this is a pentagon because it has 5 sides. So what happens here is if we're looking for X here, okay, and we know that AB is a similar side to PQ. And we know that BC is a similar side to QR. Okay? And we know that DC is a similar side to SR. So what we can do is we can generally go little over big. So we're going to go 3 over 4.5 equals 4 over y. And we're going to solve that. And then we're going to do 3 over 4.5 and x over 3. So we're going a little over big. So there's where we're solving for x. We've got x over 3 equals 3 over 4.5. We do the math. We find out x is 2. Here we have the y over 4 equals 4.5 over 3. This time they did big over little. And it's okay to do little over big or big over little. And they solve it and get the same answer. This problem here says Monique plans to remove a tree from her backyard. She needs to know the height of the tree. Monique is 6 feet tall and determines that when her shadow is 9 feet long, the shadow of the tree is 45 feet long. How tall is the tree? So here we're using similar triangles. Okay, so we know that we're trying to find x, and we know that she's 6 feet tall. So we can go big over little, x over 6 feet. We know that the tree has an angle measure of this side of 45. Her is 9 feet. That's the shadows. So we're going to go 45 over 9. So we're going big over little. X over 6, 45 over 9. And they're doing the same thing. They go x over 6, 45 over 9, proportion, cross multiply, 9 times x, 6 times 45, divide by 9, you get x equals 30. So the tree is 30 feet tall. All right. Congruent figures. If the corresponding sides of two similar figures are the same length, the figures are called congruent. Corresponding angles of congruent figures have the same measure, and the corresponding sides are equal in length. So this one says triangle ABC and A prime, B prime, C prime in figure 2 are congruent. Determine the length of A prime C. Well, if we look at this, if AC is 26, then A prime C is what? 26. Because see, it's written in such a way that AB is the same as A prime, B prime. BC is the same as B prime, C prime. And then AC is the same as A prime, C prime. So if we go to B, it says the length of side AB. So if we look on side AB, we go look for A prime, B prime. And A prime, B prime is 21.2, so AB, which is down here, is 21.2. C says the measure of angle C prime, A prime, B prime. Well, if we're looking at C prime, remember the middle point here is the vertex. So here's the vertex that we're looking for here. So we go here, it's 60 degrees. D says measure of angle ACB. So C is the vertex. So we're looking for C, which is right here. So we go to C prime, it's 50 degrees. Measure of angle ABC. So we're looking for B, which is here. And so what we have to do is we have to add these two angles together and subtract, and we get what B prime is. So it's 70 degrees. Make sure you understand on page 462, they list the types of quadrilaterals we have. We have a trapezoid where we only have one set of parallel sides, the other side is not parallel. Parallelogram where we have two opposite sides that are parallel. Rhombus where we have two sides that are parallel but the sides are all the same length. Rectangle, opposite sides are parallel and the same length. And then we have a square where all four sides are the same length. If you look here, it says trapezoid ABCD is shown in figure 8.24. Determine the measure of the interior angle x. All right, so if we want the interior angle of x, remember our corresponding sides. If this is 130, this is 130, y. And so if we subtract 130 from 180, we find out x is 50. And so there we go.